Hello, geometry folks, and welcome to Unit 7. So today we're going to start Unit 7 by talking about the Pythagorean theorem. Finally, one of the most important formulas we're ever going to talk about in geometry. We're doing that today. I'm so excited. So today we are going to focus on the Pythagorean theorem. Hopefully you know what that is and you used it. If you don't remember, hopefully those skills will come back to you. Now remember, the Pythagorean theorem is used widely outside of the classroom. It's very popular. And so it is very important that we learn how to use the Pythagorean theorem. All right, so let's get started. Now that pencil up in the right-hand corner says I need to take notes on every slide with that pencil just to make sure that you remember that. So today we're going to go ahead and start by talking about the Pythagorean theorem and how it focuses on the right triangles. So the Pythagorean theorem is used for right triangles. And now if I have this right triangle, yep, go ahead and write this right triangle down, draw it out in your notes. We have to know that right triangles have sides that have special names. So each side has a special name. If we talk about where the 90 degree is, on either side of the 90 degree, we have legs. The sides are called the legs. And then across, over there, from the 90 degree angle is called the hypotenuse. Okay, so if you're thinking, what's the Pythagorean theorem? You're probably right. It is a squared plus b squared equals c squared. But in symbols and the meaning behind what the Pythagorean theorem is, it is really the leg squared. So if you take the leg and you square it, plus you take the other leg squared and you add them together, you will get the hypotenuse squared. Okay, and that we will be studying why that is and the history behind that in days to come. But today we're going to just focus on the a squared plus the b squared equals the c squared. And so you also need to know that the c represents the hypotenuse. So if you're ever in doubt, find that right angle, go across from the right angle, you'll find your hypotenuse, and remember that always goes in for C. Okay, so how do we use it? And you don't need to write this down, but we're going to kind of remember how we use it. So how we use it is we use the formula a squared plus b squared equals c squared. Why is it used? Well, it helps me find a missing side of a right triangle. So how do I do that? Well, first and foremost, I take my formula and I plug in my sides to the corresponding a squared or b squared or c squared. Well, what I always do is I find my right angle, find my hypotenuse, and then plug that into my c. So that'll be my x squared. And then my legs are the other two, the 4 and the 3. Now it doesn't matter which one you put in where, so I'm just going to go ahead and do 4 squared plus 3 squared equals x squared. 4 squared is 16, 3 squared is 9, 16 and 9 make 25, 25 equals x squared. Now that looks a lot like we've been doing. So if I have an x squared, how do I get rid of an x squared? How do I cancel that out? I would square root both sides. Okay, so if I square root an x squared, my square and my square root cancel, and I'm left with an x, and the square root of 25 would be what we have been doing, is plus or minus 5. Now, in this case, it's only going to be a positive 5 because we're talking about the length of this side. And lengths can't be negative, so it would only be a positive 5. All right, so now let's go ahead and do a couple of examples. Put these in your notes. All right, so I have a triangle that has 6, 10, and x. So I'm going to write a squared plus b squared equals c squared. I'm going to determine which one is my c squared. Oop, there's my right triangle, my right angle. There's my hypotenuse. My hypotenuse is x squared. Then the other two are my legs, my 6 and 10, and I'm going to plug them in any order. 6 squared is 36, 10 squared is 100, x squared. 36 plus 100 is 136 equals x squared. Square root both sides. x equals, now I got to break down the square root of 136, finding the largest perfect square that goes into 136. I'm pretty sure that's 4, and 34 make 136, and the square root of 4 is 2. The square root of 34, oh, it doesn't have 1, so we keep it that way. And the answer would be 2 square roots of 34 equals x. Now remember, we don't want any decimals because they're not as accurate as simplifying the radicals. Okay, so make sure that you simplify your radicals to the fullest. Okay, let's go ahead and do example number 2. Again, write this in your notes. I have an 8, an x, and a 15. Now, this is where my right angle should be. And so right across from that right angle, bloop, there's my c squared. So a squared plus b squared equals c squared. C is 15, so 15 squared. The other two are my legs, or a and b. So 8 squared plus x squared equals 15 squared. 8 squared is 64, plus x squared equals 225. Subtract 64 from both sides. I get x squared equals 161. Square root of both sides. I get plus or minus the square root of 161. Now, again, remember, it's only going to be the positive because I'm looking for a side length, and I do not believe that 161 can be broken down. So we would leave it as the square root of 161 is that x. And remember, that's a leg and not the hypotenuse. Okay, so what is a Pythagorean triple? Okay, again, you need to write this down. It is a set of 3 whole numbers that work in a Pythagorean theorem. So remember, what are whole numbers? Whole numbers are 0, 1, 2, 3, etc. So what if I were going to give you this problem on an ACT and I would ask you which one of the following is a Pythagorean triple, which one could you get rid of right away? Well, this is the one that I could get rid of right away, A, because the square root of 5 is not a whole number. Now, how am I going to determine which one is a Pythagorean triple? So how I do that is I use the a squared plus b squared equals c squared formula, and I plug in each one of these parts. Now remember, c squared is the hypotenuse, but remember, it's always the longest side, okay? So when I'm looking at these numbers, 9, 16, and 20, I will know that the hypotenuse is 20. All right, so I'm going to plug in the 9. 9 squared plus 16 squared equals 20 squared. 9 squared is 81. 16 squared plus 81, I'm going to do that in my head, comes out to be 337 equals 400, because 20 squared is 400, and that does not equal. Therefore, that is not a Pythagorean triple. Okay, so now we're going to try out C. It would be 4 squared plus 4 squared equals 16 squared, and the 16 would be the hypotenuse because it's the longest side. This would be 16 plus 16, which would be 32, equals 256. That doesn't work, so that would not be a Pythagorean triple. So D would probably be the answer, but let's make sure that works. So 9 squared plus 12 squared equals 15 squared, and remember, the largest is the hypotenuse. 9 squared is 81 plus 144 equals 225, and I believe 81 plus 144 equals 225. And 225 equals 225, therefore this would be considered a Pythagorean triple. Okay, so now that we know what a Pythagorean triple is, let's go ahead and use the Pythagorean theorem in a formula. And area is one of those formulas that we're going to be using a lot this next semester. So let's go ahead and use the concept of Pythagorean theorem within this problem. All right, so let's talk about what the area of a triangle is. The area of a triangle is area equals 1/2 base times height. All right. So we are looking at this triangle. Oops, excuse me. We are looking at this triangle. And what do we know about this triangle? Well, we know that it has a base of 8 inches. So area would equal 1/2 8 times the height. Now, these 12s are not the height. The height is this part that goes straight up. Okay, it's the altitude. All right, so this is the height. So we're looking for the height, and we don't know that height. So we're going to have to find that height. So if we take a look at this triangle, and we look at this half of this triangle, remember when you find the height, that makes a 90-degree angle there, and we have a triangle, and so we have a 90-degree right triangle. So we can probably find h based on the Pythagorean theorem. So across from this 90, boom, there's the 12. That is your hypotenuse, so that goes in for C. So that's 12 squared. And then h is going to be one of those that we're looking for. And then what would this side be? Well, this side would be half of 8, which would be 4. So then that would be 4 squared. So 4 squared is 16 plus h squared is 144. Subtract 16 on both sides, and we get 128, the square root of both sides. Remember, we want it simplified. So the square root of 128, the largest perfect square that goes into 128 would be 64 and 2. And the square root of 64 is 8 square roots of 2. So then we would plug that back in for h. 8 square roots of 2. And now what we can do is we can multiply this through and find the area of this triangle. So what I would do is I would take 1/2 times 8 times 8, which would be 32, because a half of 8 is 4, and 4 times 8 is 32. So this would be 32 square roots of 2 inches squared, because the base is in inches, the height is in inches, and inches times inches is inches squared. Now we could put this in our calculator and get approximation, but remember that is not as accurate as 32 square roots of 2. But if we did that, we would get 45.3 inches squared. Okay, and that's all I have for you. So we'll see you tomorrow, and have a great day.